Welcome to the computer graphics practice video. The task is Bezier Spline and this is the JavaScript video. Now in this task we'll be creating Bezier splines, and if you look at the materials, in the material we had those Bezier curves here, this example, and when you added a new segment, then it just creates a new segment in the end of the previous one. So both those curves in this spline share this one control point. And so this creates you this C0 smooth spline. It is like continuous in the sense that you can move along this spline without any jump from one curve to another. Now in the task that we have, the idea is to end up with C1 and C2 smooth Bezier splines. So if you think about the shared control point of two curves, then in C1 case the derivative here needs to be smooth, and in C2 case the second derivative needs to be smooth. Both the derivatives of course are smooth along this cubic curve, but the question is those shared control points where the both endpoints of the curve pass. But in order to draw these curves, we actually need to kind of see that we're not only drawing a curve here, but we're drawing also the control points and lines between the control points. So this is just for showing like how are the control points set and how does the curve follow based on those. Now if you download the base code, you should be able to get this file, and in JavaScript what we have in this task there are two kind of sets of points. So one is this test set of control points. So those are fixed values, they're scaled and translated a bit, but basically those are kind of used to see that the result is correct. So in the task as description, the first drawing uses the control points from the test set. The second one is just arbitrary random values. So this is in this get random curve control points. It just creates you a bunch of random control points in the scene. Now you can switch between the two sets via arrow keys. So if you open it in a browser, then initially it's black, but if you press the left and right key, then it switches between C1 and C2, and if you press the up and down key, it switches between the random and test sets. Now there is this function create spline. So this should create you this spline structure, and I'll show how it should be in a second. There's also create spline C1 and create spline C2, and those will kind of be those smoothness functions. So if you want to render a C1 smooth spline, then the smoothness function is this C1 spline, and otherwise it's with the left arrow you can switch to C2 smoothness, and then it's create spline C2. Those will modify the control points such that the overall spline will be smooth enough. Now this is probably not the most optimal way of doing this, but what we're currently doing is we have this one object named spline, and each frame we remove it from the scene, and then we add it back with the newly created set of control points. And we actually need this here because one part of the task is to apply some changes to the control points, apply a transformation on them, and see what happens with the spline. So we actually do need to recreate the splines each frame the points are modified. Otherwise you could have like this smoothness function just in the input handling part, where you press a key and then the control points change. but currently because of this transformation we have it here and create a new object here. Actually, we won't be like creating the whole curve, so if you look at the create spline function, then we should kind of check, do we already have a spline with the correct structure, and then we just update the vertex data, or if we don't, then we need to create the structure as well. And the structure should be something like this. We have a spline which consists of a couple of things. First, it consists of points. Maybe I should write this with P. Then it consists of lines, and it also consists of curves. And there are several curves depending on how many segments you have in the spline. We have the points, so those are the control points, all of the control points of the curve. Then we have the lines, so those are the lines between the control points. And finally we have the curves. Those are also lines, but there are so many of them so that they look like curves. So different curves along the spline inside those control points and the lines. Okay, so this is the overall structure of the object we want to create. So let's try to create that. So if not already created, so basically I think what we can do here is we can have some variable, and we currently don't have one. Let's create a variable, so current spline. And we could also use that instead of taking the spline by name here. Okay, so if that is not null, then first we create a line mesh. So it's lines, it's a new, and now I have to see in the 3JS documentation again, do we have lines, drawing lines, line basic material is probably what we want to use, objects line. So let's see this. So there's even an example, so tree line, not mesh, and there's the line basic material, and there's the geometry where the vertices are kind of the points on the line, so it's a piecewise linear line. And it's also connected. So you can see that what's written up here is that there's also this line segments, but the difference is that this is rendered using a line strip instead of lines. So with lines you could have like lines which are like independent of each other, but with line strip they all go in one continuous spline, linear spline. So we have this new tree line which we need to create. So geometry. What should be the geometry? It's a new geometry. What about the vertices? So actually when you look at this create spline, it gets the points as input. Those actually are the vertices, so those are already points on the in the space. So those points need to be the vertices here. And we also need a material, and that is a new tree line basic material. And you can pick a color, let's say yellow, and we'll see how it looks. With this we might be already be able to render something. So a current spline, in the end what we want to do is we want to return the spline. So basically, well, we can return this current spline. Here we do need to say that this is a new say object 3D, and we add the lines mesh to it. What else we maybe want to be able to get these lines afterwards via name, so we can do something like this as well. Okay, and let's see the result. Yeah, we get an error, so one mistake I made was here. So if it is null, and this is much better. So now we see that those lines are here. And this is the test set, and when I okay, it currently doesn't make it smaller, doesn't update because it only creates it once and it doesn't update it here. But we could create an else now, and now we're going to try to update the data. And for this, we have the current spline, it is not null, and we can take the lines out of it by get object by name lines. And because the points have changed, all we need to do is change the points in the lines geometry. And we also need to call this geometry vertices need update, because we have changed the vertex coordinates. And now if we do this, it doesn't get update because this vertices needs update is also in the geometry, not in the mesh. And now we can see that those will be the new points, and this is the test set. Okay, so far so good. Just in here, this vertex needs update is on the geometry. Okay, let's also try to create some points to see the control points. So in 3JS, there's the line, and there are also points which will have the points material. So pretty much the same thing. Now we have points, which is a new 3 points, which are geometry and material. And I think it shouldn't break anything if I just create a new geometry here. So new geometry, the vertices are points. Some of you might be thinking, could you reuse this because it's the same thing? Maybe. I think in some versions ago this had a problem that it wouldn't draw one or the other, but you can try this out. And as for the material, we have the points material, not basic line material. Maybe this is yellow as well, and points, and let's say that points has a name which is points, and let's add the points to the current spline. Okay, and do we get something? Yep, so now we get these points. We also need to update them, so down here we also update the points, and these now points. Similarly, what we did with lines, and well, we had this one problem here, that the points are now used in 2 names. So maybe we name this thing control points. So those are the points that are sent as input, or maybe even because the comment says that this is control point, so maybe this would be a better thing, that we name this control points here, and this is what we add. Also we can use the name control point, take control points, and this is also control points, and this is what we update with points. Okay, and let's see now, and now the points, control points are also updated. Okay, as for the actual curves part, now we need this container. So we need curves, new, let's say object 3D. It has a name, curves perhaps, and we need to add to it as many line objects as needed. So how many are needed? And it depends on how much we sample different curves. So what we're going to do is basically we have the control points. Say we have some set of points, and in pre-JS there is a class for a Bezier curve, and that Bezier curve allows you to specify points, and you can get the curve based on those points. And you can sample different points on that curve. And this is what we're going to use. Then we're going to use lines to rasterize this sampled curve. Okay, so for this we will need a loop here, and how long that loop should be. So the goal is to create those curves between all of the control points, and if we output the control points, we see that there are 16 control points, but the middle ones are shared between the curves. So let's take the first one, so that starts here. So for the first one we need the first, second, third and fourth control point. For the second one we need to start from the fourth one, take the fifth, sixth and seventh. And for the third one we start from the seventh and take so on. So our for loop starts from 0, goes, so let's say until the end of the points, but this is not like entirely true. It's more like points -1 or points -3, because depending on if you start here and what we're going to do is we're going to move by 3 points. So when we start at 0, we move 1, 2 and 3 and we end up here. Then we again move 1, 2, 3, 1, 2, 3, 1, 2, 3, and if we continue 1, 2, 3, then we end up in the last point. So this is what we don't want. Even if this is a valid point, we can't create a new curve segment from there. So the loop is like this, and each iteration we're going to create a new cubic Bezier curve inside this. So it will be curve, and now we probably want to go see the pre-JS documentation again. So this was here, and is here. So we have this cubic Bezier curve and cubic Bezier curve 3. So this is a 2-dimensional curve and this is a 3-dimensional curve. Okay, we probably want to use that one. And you can see that the constructor takes 4 control points because it's the cubic curve. Then this is basically what we want. So let's put this here. And now what are the control points? So those are the points from the points array. Like we discussed, the first one is the ith one, so basically I plus 0. The second one is I plus 1, I plus 2, and then the I plus 3. So you see that we take the 4 control points in sequence, but we iterate 3 at a time. So this makes them share this last control point. Okay, and based on those curves, now what we can do is, if you remember from the previous tasks, we had this light trajectory which also was on a curve. So there is this method in the curve class get points and number of pieces to divide the curve into. Or I think there's also this new function with space points, which might also be useful. So let's try this curve get points, and how many do we want? Let's say, or maybe 10. So what are we going to do with those points? Basically we need to create a new line mesh, so a new pre-line with some with some geometry and material. Now the material isn't going to change, so we can create the material already before this loop. Maybe this will be now red or white or whatever, and the geometry, this is something that we do need to create. So we have a new geometry, which is geometry, and its vertices are those points. So geometry vertices is those points on the curve. And we add those here. This new line mesh, what are we going to do with this? We're going to add it to the curves object. So now curves container will consist of many curves. Each are line meshes that have their geometry sampled from this cubic Bezier curve tree. Okay, let's go see what happens. So object 3D is not defined, so this one should be namespaced. And let's see again. And we yet don't see anything, so let's see the code. This curves object isn't yet added to the current spline, so let's add it as well. So the third children here. And now we get to see those curves that are drawn based on the 4 control points between the control points. Now this doesn't yet update. In order to update this, down here we actually in the else block we actually do need to have this loop again. Based on the new points, we create those new curves and we sample new points from them. But let's see. So first we need to have this curves part. So this is same as here, only now we take the curves. And inside this we have different line meshes. So we actually don't need to create a new line mesh. So this line mesh we have, and for this we need to take the curves, its children, and now the question is the index. So basically we have divided the points array like by 3 here, sort of. So we need like have a sequential number here. I think the quickest way what we can do is we can floor I divided by 3. So when it's 0, we get the 0th child. When it's 3, we get the first child, and so on. This is the line. This line has a geometry, has the vertices, and those are the vertices that we update via this new curve. And this one we don't want to do because it's already attached to the curves object. So let's see again. And it doesn't yet update because there is one more thing missing, and it is this geometry vertices need update. And now we can see that we can update the curve with the control points, and it changes. Now this C1 and C2 yet doesn't do anything, and for this we need to have we need to first see how to create those C1 smooth curves. The main idea is to modify the control points, and if you read through this, you can see that, well, intuitively you can think that for the first derivative you basically need those segments here between the two curves to be equal. Intuitively gives you that if you move along this line and continue moving on this line with the same speed, then the derivative is equal here. You can of course find out more about it. So here is this interesting derivation of how to get different derivative values for Bezier curve knots, and it turns out that the derivative at the endpoint is 3 times the last segment, and derivative at the start is 3 times first segment. So if we take those to be equal, then we can simplify this equation and see that basically yes, this is exactly what we want. We want the middle, the point here, the shared point, to be exactly between the third point here or the first point here. This kind of indicates that if we have this one, like those are two curves here. Now if we have three curves, so the blue one, red one and green one, then all of the middle curves need one less control point to be defined. So you can see that the end curves yes need 3 control points. The fourth one is automatically calculated to be between those two, but the middle ones need two control points, and the last one still needs 3. So remember before, like we had the first segment needs 4, and then the second one needs 3, 3, 3, and then 4 again, because for C0 we need to share the point in the end of one curve and in the beginning of another. But now also like the endpoints have a new automatically calculated value, so all the segments need one less control point. And the result should look something like this. Now how to do this? Let's see what's happening. So create spline C1, modify the points here. Currently it just returns the create spline again, so both of those functions return the create spline, and they just send pass those points through. Now what we can do here is we can modify the points, and then we no longer have this C0 with what we currently have, but C1 curve. So in order to modify the points here, we need to think how to loop through the points such that we get the correct point we want to modify. And it shouldn't be too difficult for C1. So for example, if we have these, and let's make some more points here, maybe 2 segments. So point 0, 1, 2, 3, 4, 5, and maybe some more 6, 7, 8. Will there also be a 9th one? I think not. So the points we need to modify are the shared points. So this 3 here, because it's 1, 2, 3. Fourth point here, and first point of this segment. So the first point, second, third, fourth point, first point, second, third, and actually there is supposed to be, I think, one more, which is the 9th. So we take every third point starting from 3. This should be the correct loop. So let's try it out. We start from 3. We loop until, and we again don't want to accidentally end up on the last point. So points length -1, for example, and I equals or increases by 3 each time. Now, assuming we can now take the point E, which we want to change, what do we want to do with this? Basically, we want it to be in between the previous point and the next point. One way to do it, and I think it's also it's basically written here as well, so take the sum of the previous and next point and take half of this sum, so this puts it in the middle of the two values. Multiple ways to do it. I think creating a new 3 vector from this vector 3 is also is fine. Now to this, what we can do is we can copy points and it's points I -1, so this copies the previous value. Then we add to it points I plus 1, it adds the second with the next value, and we do a multiply scalar with 0.1. And this should actually be it. So let's see if we made any mistakes. And looks good. Now this C2 currently just passes the points along, but the C1 now modifies the points, and we can see this point becomes a point in the middle of the previous and next point. This one, middle of previous and next. This one here as well, and this one as well, and the last points stay fixed. So this is what we intended to do. And if we look at the drawing here, then it looks pretty similar to what the task description says should be your result. So this is a way to check your result, compare your result with the one in the task description, and this is the same thing. Now for C2 smoothness, you need to be a little more not creative, but think a bit. So for C2 it's not that intuitive. For the second derivative at the end of one point, this is actually 6 times the last point minus 12 times the point before plus 6 times the point before. And for the starting, it's 6 times the current point minus the 12 times the next point minus 6 times the next point. So this is again derived in this link. You can see how it's calculated. But from this equation, we can try to make the derivatives equal. So in order for the second derivative to be equal in the knots between the curves, we need this condition. So those two need to be equal. We can divide them by 6 and get this equation. And then we can start rearranging the terms. So you can see that there is P3 minus P2 here. Let's pull this out. And what's left is P1 minus P2. Same thing on the other side. Q2 minus Q1 and Q0 minus Q1 is in the last term. What we can do with this is we know that P3 minus P2 is the same as Q1 minus Q0. Because if we want to talk about C2 smoothness, we have to assume that there is already C1 smoothness. Otherwise C2 can't be smooth. If you look what we did here, P2 to P3 is the same as P3 to Q1 or Q0 to Q1. This is how it's defined. So those things need to be, well, are already equal. Based on this, we can substitute those values here, and we can, for example, if we substitute this Q1 minus Q0, like here, we replace it with minus P3 plus P2, so minus that value goes here because it's the other way around. And so maybe I can, like, if this might be a bit complicated, and we can also write it here. So otherwise it might be difficult to follow. What do we have? We have P3 minus P2 plus P1 minus P2 is equal to, okay, this went a little small here, plus P1 minus P2 is equal to Q2 minus Q1 plus Q0 minus Q1, right? So this is what we have, and we also have this condition that P3 minus P2 needs to be equal to Q1 minus Q0. So the C1 smoothness is already here. And now if if you take like q1 minus q0, this is here with a negative value. Basically this is minus p3 minus p2. This term here. And if you move it to the other side, this part becomes plus p3 minus p2, so it's 2 times p3 minus p2 because of that. And what else? So we can do the same thing for this q part, so it would be the same thing, but we can also like write out that we are left with q2 minus q1 minus p1 minus p2. So, or alternatively plus p2 minus p1. So 1. And yeah, if we do the same thing for the q part, so we replace it from the other side and bring the term to this side, then this is also equal to 2 times q1 minus q0, right? q1 minus q0. So you can substitute that p3 minus p2 with this value, q1 minus q0, and pull it to the other side. You get 2 times q0 minus q1, and if you move it back to this side, then you get this 2 times q1 minus q0. Now this is all great arithmetic we're doing here, or like simplifying of formulas, but what does it actually mean? So this last value tells us that if we take a vector from p2 to p3, so basically this is this vector here, so from p2 to p3, and we take 2 times of that, then this length needs to be, or this vector needs to be equal to the sum of p2 minus p1, that's the blue vector, and q2 minus q1, that is the red vector. So this is also maybe something we should try to draw. So this is believable, right, that we get this equation. And now when we have those control points, so let me see if we have p1, p2, somewhere we have p3, oh, those p's are all upside down, which is equal to q0. And now we also know that this p3 it needs to be in the middle of p2. We also have p0 somewhere, right? Middle, exactly in the middle of this p2 and q1 and q2, and lastly somewhere q3. So those are our control points. Now, what the formula says is that if we have this red vector which is from q1 to q2, so that one, that is this q2 minus q1 in the formula, so q2 minus q1, and we have this blue which is from p1 to p2, which is basically p2 minus p1, right? So that's that vector. Then the sum of those needs to be this length of this vector, basically that whole vector. And what it tells us is that the points need to be arranged in a way where if we extend this part by the same amount to that way, and we extend here by the same amount that way, this line, then those two need to end up in one point. Well, currently they don't, so this set of control points doesn't give us a C2 smooth spline. But it is possible to arrange the points in a way where they do end up in one point up here. So, for example, if we happen to have this point a little bit further away, so maybe somewhere like here, or maybe even a bit more further away, then our P2 minus P1 is a bit longer, ends up somewhere there, and the same thing we can do down here. So our Q2 would be here, but of course somewhere there is also Q3 and this is P1 and somewhere there is P0. Then our red vector is also a bit larger, and they end up in, let's call it a same point somewhere up here. So this point is called kind of a tip in the task. So this is actually the only point you need to define. If you have defined this point, then everything else you can calculate. So of course, like you need to also define P1, P0 and P1, and down here, if this is the last spline, then you need Q3 and Q2, and then this one point in there as well. But if this is not the last spline, then things change again. Now, if you have defined this, then you can just take P2 to be exactly in the middle of P1 and this tip, and you can take Q1 to be in the middle of this tip and Q2. And this ensures you that the distance here is exactly the sum of the blue and red vectors. At this middle point, well, this is just C1, so this you can put in the middle of newly found Q1 and P2, and then you have also guaranteed the C1 smoothness and everything works out. So this is what has been tried to depict on this illustration here. You can also see the same thing down here. So if you add the blue and red vectors once, you get halfway here. You need to add them again, you get another halfway here, and so this also works out if you try to derive it down here, like how should the different points be oriented. But all you need is this tip value, and those values I think are some of the values in the set. So it's probably some of those comments are a bit off. Now, one problem you might have is when you have a sequence of those curves. Here there are four curves: the blue one, the red one, the brown, and the green. Now, what's happening in the middle here is that if you have those P0, P1 defined, a tip defined, then for the next segment you also need to define a tip, right? Because there are now two conditions. So this red line here and this one here need to be equal, right? So this is what we got here. Now we need to put this point in the between those 2 points. But the same condition holds for the next curve. So this length here and this length here need to also be equal. And if you have three lengths which need to be pairwise equal to, the first two need to be equal and the second and third need to be equal, then they all need to be equal. And so you have one line which you want to have three equal segments. And those will find you the Q1 and Q2 point locations. What will happen is that you get values P0, P1, tip 1, tip 2, and so on until the last R2 and R3, and the middle segments you need to divide by 3, so get like 1/3 of the length between from tip 1 to tip 2, 2/3, and those are the 2 points, control points in between. So this is also specified here, that these need to be equal, these need to be equal, and last you also have 2 segments like in the beginning that need to be equal. And in the middle there are 3 segments that need to be equal. And those points you then move to have the C1 smoothness as well. And in the end you should get this result. You can also check out this PDF. It includes the different formulas, how much of each point you need to take in order to end up with correct spline. But also be mindful that what is our numeration of points here and what is the numeration of points here. So this is a bit different. But it should help you write the last function here, so this spline 2D. So modify different points, and in the end you also have to modify some other points. So see how to do it. And the last thing in this task would be to then apply some scale changes for the either the points x coordinate or y coordinate. So the idea is not to apply a matrix on those, but to calculate new coordinate values right here in the draw loop. So basically just modify the points such that their x would change in time, like would be scaled in time, or y would be scaled in time. See if something happens with the curve that you wouldn't expect or not. So come up with some formula that scales the points here. That's pretty much it about this task. I hope you find it interesting. So understanding something geometrically as well as we did some arithmetics here. So it's this interesting topic. I hope you have fun with this task, and good luck.